In Chapter 4 of Volume 1, we go over radicals and rational exponents. The first thing we look at is the difference between the square root of a number and the principal square root. If we're looking down here at the definition of the square root, we see that we have b squared equals a, where the number b is the square root. If we take a look at b squared equals 25 and use the solve command, we see that we actually have two numbers that are square roots, either -5 or 5. If we look at 49, we have two numbers that can be equal to b squared equals 49, either -7 or 7. When we're dealing with a negative number, this turns out to be false. There is no negative number. There is no number squared that gives us a negative. If we're dealing with an irrational number, like b squared equals 10, it turns out to be minus the square root of 10 or the square root of 10. Let's go to the next page. When we're working this problem out with the numerical version of the calculator, it does not have the solve command. It has the nsolve command. The nsolve command also exists on the CAS version of the calculator, but since we have the solve command, we will not use the nsolve on the CAS. Here, it only gives us one of the answers when it's in this form. If we tell it where to look for the answer, here we say look between -6 and 6. Again, it only gives us one of the answers. But if we tell it to look between -6 and -4, it will give us the -5. Or we tell it to look between -6 and +4, it will give us the -5. Rather than give us both the answers, it only gives us one of the answers because we tell a range to look for the answer. When we're dealing with the principal square root, we're dealing with the radical symbol. So in this case, when we have this answer, we're only dealing with the 5. When we have the square root of 25, the square root of 49, we're only dealing with the 7. When we have the square root of -16, there is no answer for that one. Again, we see this written out on the scratch pad page. So when we have the square root of 25, like we said, and have the radical sign in there, it indicates the principal square root. So the square root of 25, 5, square root of 49, 7, square root of -10, no real number. Square root of 10 comes back with the square root of 10. Square root of 10 comes back with 3.1628 if we use approximately equal to that. Again, this would be from the CAS calculator. If we're dealing with the numerical calculator, this one will be written as the last entry. We can generalize this principal square root by going to the principal n root. So if a is equal to 0, then the principal nth root of a is equal to 0. If a is greater than 0, then the principal nth root of a is equal to b. If a is less than 0, then the principal nth root of a is, and n is odd, is equal to a. But if it's even, then the nth root is not a real number. Just like over here, when we took the square root of -16th, if we take the fourth root of a negative number, we will not get a real result. We can see pictures of the square root and the raised to the second power in this math activity from TI. What happens is, picture of the graph, there's no negative part for the square root picture. But when we move to an odd root, like the 7th root, or raising to the 7th power, what happens is the 7th power both has positive and negative answer, but the 7th root, will also have positive and negative answers. We're up here on the square root, we will not have any negative part to our graph. But for the square, we both have, for positive numbers and negative numbers, our answer. Instead of using the math activity, we can bring up on the scratch pad and draw pictures of what these look like. Here we see on the next page examples of our principal nth root. The fifth root of 0 is 0. The fifth root of 32 is 2, because 2 times itself 5 times is 32. The fourth root of 16 is 2. The fifth root of a negative number, in this case minus 32, is minus 2. But when we're dealing with an even power, the fourth root of negative 16 turns out to be error, no real result. Let's go ahead and look at these answers on our calculator. So go over to the scratch pad. If the scratch pad has information in it, use the action 1-5 to clear out your calculator. So the first thing we're going to look at is the one dealing with the principal square root when we're dealing with 0. So we want to take the fifth root, so we'll hit Control, put 5 in for our index, move over, put in 0, and press enter, and we see the answer is 0. The next one we'll want to look at is an odd exponent for a positive number. So we'll hit Control, get our index to be 5, move over, 32, press enter, get the answer to turn out to be 2. Next, we will want to look at an even index. So bring up the nth root, put in 4, move over, put in 16, and we see the answer turns out to be 2. The next, we'll do an odd index of a negative number. Control, fifth, negative 32, and we forgot to move over, so we have a syntax error. So let's correct this. So we'll delete this part. We'll move over. Oops, we still got to go back. Still got a negative sign. Now we'll move over. Put in the negative 32. Press enter. Get negative 2. And the last thing, we're going to look at the index of a negative number with an even index. So bring up our template, put in 4, move over, put in negative 16, and it gives us a message, non-real result. It tells us we can change the settings to actually come up with an answer. After we read this message, we'll press enter and see that it prints out in our entry, error, non-real result. We will now take a look at some observations that will lead us to the properties of radicals. So the properties of radicals are listed here. We're going to look at some observations that have to deal with this. If we take the square root of 4 squared, we end up with 4. This is like taking the nth root of a to the n power with the index here understood to be 2. If we deal with negative 4 squared, if we do it manually, this would be 16, which would be the same as 4 squared, which would turn out to be 4. But using our rules, what happens is when we take the index of an even, it turns out to be the absolute value of a. And to show this in a little bit more detail, when this a is less than 0, it turns out to be the opposite of a, which is a positive number, because since a was less than 0, the opposite of a is a positive number. Again, let's go over and look at these on our calculator. So we will want to go to Menu, 1, 5 to clear out our calculator. Hit Control, Radical, 4. Since we want to square it, we'll just use the square one. Press Enter. Next, go to Control, Radical, parentheses, -4. Move outside the parentheses. Square it. Get 4. Go to square root. Put in A. Square it. Get absolute value of A. To look at some of the details for this, go to square root, A, square it, go outside the radical, use the with operator. Remember, it's in this group, so hit Control, move till we get to the with operator, press Enter, A less than 0. So again, we'll go to here, get our less than symbol, put in 0, and press Enter. So we see that what happens is when we have an even index and an A squared, the answer turns out to be the absolute value of A. Clarifying this, when we're dealing with a negative number, the answer turns out to be the opposite of a negative number. So this expression here will turn out to be a positive A. So this is what we're talking about in our properties of radicals. So if we have an index and it's raised to the nth power on the outside, the answer is A. If we have an index and the nth power is on the inside and n is odd, the answer is A. But if we have an even power, okay, and an even index, the answer is the absolute value of A. If we have the nth index of 2 that are multiplied, we can break this down into the nth root of A times the nth root of B. Notice up here that M and N have to be, okay, positive integers, and A, R, and B are real numbers, provided the indicated result exists. So if we're taking the 4th root of -3 times -2, and we split it apart into the 4th root of -3, you cannot take the 4th root of a negative number. So we cannot use this rule because the roots do not exist. The same thing with splitting things apart. If we have a fraction inside, we can split it apart into the numerator and denominator. And if we have a radical inside a radical, we can combine the two indexes here. Turning to the next page, we see examples of the properties of radicals. So if we have the power on the outside, the answer turns out to be the number in the inside, which is -4. If we have the 5th root of a negative, the answer turns out to be a negative. If we have the 4th root of a negative raised to the 4th power, the answer turns out to be the absolute value of the number in the inside, so it turns out to be a +2. If we have the 3rd root of 16, the answer turns out to be split apart into the cube root of 8 times the cube root of 2. The cube root of 8 turns out to be 2, and then the rest of it would be the cube root of 2. Our calculator switches over to the rational form of exponent. The fourth root of 7 over 16, the fourth root of 16 in the bottom turns out to be 2. The fourth root of 7, again, is switched over to rational exponent form. When we're dealing with the square root times the cube root, we're dealing with the sixth root of 64. So 2 to the 6th power is 64. So the sixth root of 64 turns out to be 2. Now these answers here were for our CAS model. Now let's turn and take a look at the numerical or using the approximate key on the CAS model. So flip to the next page. So the cube root of 16 on the numerical model turns out to be 2.51984. The fourth root of 7 over 16 turns out to be 0.813288, and the cube root of the square root of the cube root of 64 turns out to be 6th root of 64, which turns out to be 2 on both models. So let's take a quick look at this last screen on our calculator. So we'll go over to here and clear out the scratch pad. So we'll go to 1, 5 to clear out our scratch pad. We'll take the cube root of 16. So we'll use this index here to be 3. Move over, put 16 in here, press enter. And since we're on the CAS, it's going to give this answer with the rational exponent for the cube root and simplify it. If we go back up here and copy this answer down and then press Control Enter, we'll see what the numerical model does. So the numerical model switches this over to 2.51984. So that's the difference between the two different models. And the same thing happens with when we're doing a quotient and when we're doing, okay, the index with inside of an index. Both models, since the answer turns out to be perfect, it's going to turn out to be written as a numerical answer. Working with radicals can be somewhat confusing, so we try to come up with some rules that will help us. So if I go to the next page, the simplification of radicals. Step number 1, if necessary, combine radicals. Remember we had the property of radical rules. Well, we can actually use this property in reverse. So we can take the parts of it and put them back together. If there's a constant in the problem, factor the constant so we can take numbers out. Then a trick that we can use to simplify them is to switch the radical into, okay, a division problem to help us with the exponents. So what happens is the index is going to be the divisor, then the power is going to be the dividend. When we divide it 2, we're going to get the quotient and the remainder. Okay, so these rules right here, you can take a look at it, show us for an odd index and an even index how we can mechanically switch things around by using this technique. When we get done, our calculator deals with positive and negative numbers, so a lot of times these problems will have absolute value in the answer. So absolute values can be split apart. A constant and an absolute value can be split apart. If we know that it's greater than 0, then that part of the absolute value can be dropped. If we have an absolute value of a number with an even exponent, there's no need for the absolute value, so it can be dropped. When you're dealing with textbooks, a lot of times they will just say that we're only dealing with positive numbers, so they will not have to handle all these situations with absolute value in the answer. Okay, next let's take a look at example 1. So if we flip over here, we see example 1 worked out by 2 techniques. If we go over to our calculator, we can hit our home key, we can hit our current, which is enter, and we see that we have these problems worked out over here on our calculator. So we have the traditional approach, our alternate approach, which is the rule we just showed you on the previous page, and our calculator handling these problems. So we kind of need to look at all these to see and understand better what to do. So the traditional approach here is to take 375 and factor it into 3 times 125, and then when we do this, we have the cube root of 3 times the 5 cubed. We can break this down into our 2 parts, and the ones with the perfect cube will go outside in the front. When we have x to the 10th, we can switch this into 5 squared because the index is 2. Since this is an even index, the answer turns out to have absolute value. When we have the cube root of this part here, we can split it apart into the ones that are multiples of 3 and the parts that are left over. Then we can split the 2 apart. We can take all the perfect cubes and bring them out. Again, you'll want to spend more time looking at this detail. The alternate approach in here, okay, since this one here 3 doesn't divide into the 1, it just gets left. 3 goes into this 3 once with no remainder, so this would be 5 to the 0 power, well, anything to the 0 power is 1. This particular one, 2 goes into 10 5 times. We're dealing with an even, okay, index, so the absolute value comes into the answer. Here, we split the 54 into 2 times 27. 27 is the same as 3 cubed. Then the power is 1, so 3 doesn't divide into 1, so the 2 is left inside the radical. 3 goes into 3 one time with none left over. 3 goes into 8 2 times with 2 left over. 3 goes into 5, okay, once with 2 left over. So this is where we switch the index into division to mechanically help us with this kind of problem. Now switching over to our calculator screen, when we type the index and 3 and the cube root of 375, we end up with the 5 and 3 raised to the 3rd power, because again our calculator switched it over to a rational exponent. 2 goes into 10 5 times. Our calculator automatically puts in the absolute value. Now on this problem, our calculator is not that helpful because it doesn't reduce the 8/3 and the 5/3. It does handle the 54 part for us because we have the cube root of 2 and 3, so we have the cube root of 2 and 3. But the rest of us we will have to do manually, even on the CAS model. Going to the next page, we see the same things over here in our calculator with the screenshot. Then we have some more problems that we can practice and go out and take a look at the solution to the problem. So again, you probably want to work these out and take a look at the solution. The next thing we do is we want to simplify ones that are connected as terms. So when we're doing the square root of 50 minus the square root of 18, we can change this into 2 times 25 and 2 times 9. Then the 25 can be the 5 out, the 9 can be the 3. Then since they both have the square root of 2, we can subtract and come up with this answer. We can do the same thing, okay, with variables in a problem. So what happens here, we switch the 27 into x cubed into 3x cubed. We take the minus x, look at this as minus x cubed in here, okay, and then what happens, since we're going to deal with this part here and this part over here, so when we have the cube root, we'll split it apart into the two. When we have the cube root, we'll split it apart into the two. Then we'll simplify this cube root y squared into this answer. We'll simplify this cubed into this answer, so the add becomes subtract. Now they both have the same radical, so 3x take away x, and it turns out to be this answer here. And you can see in our CAS model, when we put these in, it's able to handle this. Again, it writes this as 2/3, so we'll have to translate this as the cube root of y squared. Moving on, we have some unique things happening when we're using our CAS model. So let's go ahead and take a look at some of this information on our calculator. So over here, we'll go to our calculator, we'll hit the scratch pad, and we'll want to clear out the entries on the scratch pad. So menu 1-5, to clear it out, we'll put in A, we'll raise it to the 1/2 power. We'll use our template. We'll move over. We'll move down. We'll take it times A, and then again raise it. Put in our template for a fraction. Put in 1/2. Press enter. And it gives me A with a warning. Now, to see the warning, you can hover over, okay, your pad here, and it turns into a touchpad. And when you do that, you turn into a mouse. And when you click on here, it says domain of the result might be larger than the domain of the input. So let's take a look at something and see what they're kind of talking about. So let's take -4 and raise it to the -1/2, or raise it to the 1/2 power. Move down. And -4. Raise it to the power. Put in our fraction. And it gives us our answer to be 4. What's going on here is the precedence rule is taking effect. Exponent has precedence over this unary operation of opposite, so the square root of 4 is 2, and then the opposite of 2 is -2. Same thing here, and a -2 times a -2 turns out to before. So don't get confused and think that this is minus 4 raised to the half power and the answer would turn out to be minus 4. In fact, let's take a look at this with the radical now. So we'll go to square root. We'll put in a, move outside, hit times, hit square root, plug in a, and it says the answer is A, just like it did with the half power. Gives us a warning. So again, we'll hover over our touchpad. We'll click on this warning, and it gives us that the domain of the result may be larger than the domain of the input. So then, let's put in negative 4. Inside the square root. Now technically we can't do that because you can't take the square root of a negative, but let's see what happens when we tell our calculator to work this problem out. Hit times, then hit square root, plug in negative 4, press enter, and our calculator tells us the answer is negative 4. So again, we have to be very careful when we do things on our CAS calculator, because we can't just assume that this answer is correct. So we can't take the square root of negative. Well, what's going on here is our calculator switches this problem into A and then substitutes in the minus 4, and that's why it ends up with a negative 4. Now, what's kind of interesting is our calculator gives us a warning. So again, if we hover over here and turns it into a touchpad and go up with our arrow and click on it, it says that this is a non-real calculation. So when we were doing things with division by 0, it wouldn't give us error messages. We're here with radicals. When we actually plug in the radical numbers in, it actually, I shouldn't say an error message, I should say a warning. It gives us a warning because it calculated this with non-real. So even though our calculator was set to do real calculations, it did a non-real calculation automatically. So again, we have to watch this stuff. And if I take a look at control, square root, negative 4 just by itself, and I press enter, I will get this message that tells us if I want to get the answer, I need to switch the conditions over to complex instead of real. We haven't talked about complex numbers. That will be in a later volume in there. And then if I press enter to answer this, it says error is a non-real result. So again, we must be careful when we use our calculator and know what's going on manually ourselves. Now let's return over here to the screenshot. We won't do this on our calculator, but odd indexes here, cube root, will not cause us a problem because we can take the index of an odd of a negative number. And again, here we do it with the rational exponent, and here we do it with the radical. Moving on, the next thing that we show is again on the scratch pad, when we put in x to the 1/3, it leaves it as x to the 1/3. But when we put in the cube root of x, it switches it over to rational exponent. Or if we put in the 5th root of x squared, it again will switch it over to a rational exponent. Okay, let's take a look at simplifying some problems out manually or traditionally. So if we switch this to the 4th root cubed and then The fourth root of 16 turns out to be 2. The fourth root of 81 turns out to be 3. And then we have the cube outside. Since this is a positive number, the absolute value of a positive number is just itself, so it's not needed. When we take the fifth root of 32 and it's negative, moving the negative down to the denominator, taking the fifth root of 32, since it's odd, we don't need absolute value, and it just turns out to be that answer. Let's take a look at these on the calculator screen. So on the calculator screen, we see that it turns out to be 8 over 27, and it turns out to be 1/2. So these will work with both models of the calculator. That's why we have it listed as family. Now, if we're working these problems out manually, we can use the list and spreadsheet page to put in numbers, and then we can square them, cube them, and raise them to the 4th power. And when we start working out problems and we're doing it manually, it kind of wants us to know that these numbers or multiples of these numbers can be simplified. So we can use our list and spreadsheet to help us. Here, read this to see what's going on. To simplify -8 to the 2/3 times 9 to the 3/2, we again do this work out over here and get our answer to be 108. And on both calculators, the numerical and the CIS, when we put it in, we will end up with this answer. Then when we do things with variables in the expression and we work this stuff out, then over here we get this answer on our calculator. So go ahead and take a look at the details shown here. Moving on, reducing the index. So if we have 8 and 4 and 4, it will show the answer with absolute value. Again, our textbooks will normally say that we're only dealing with positive, so it will not handle absolute value in its answers. When we're dealing with the 6th root of 3, it does not reduce the answer for us, but if we switch it over to an equivalent form, the 6th root with the 3 outside, it will reduce the index. So we have to remember that when we're working problems out to switch it over to an equivalent form. Simplifying radical expressions, here's some rules for us. Convert radicals to exponents. Use arithmetic and properties, of exponents. As necessary, convert back to radicals. So here it shows a problem where we follow these rules. We convert over, we reduce the rational number to 1/2, then we convert back to radical. Again, it shows us working these problems out. It shows us dealing with the absolute value. In textbooks, they will say that the numbers are going to be non-negative, which it means 0 or positive, so you won't have to deal with the absolute value. But because we're dealing with our calculator and it does not have that restriction, we put in the absolute value. So you can take a look at this. And if we flip over, you can see these problems worked out with our calculator with absolute values being in the answer. And here again, if we don't switch it over to an equivalent form, then the calculator will not write the answer in the simpler form. So it's up to us to switch it over to this equivalent form. When we have the square root times the 5th root, we can switch these over to fractional exponents. We add the 2 together and switch it back. We have the 4th root, of a cube, and the cube root here, switch it over to fractional exponents, subtract them, switch it back. Here it shows these things being worked on our calculator. The last thing we're going to do in this chapter is rationalize the denominator. So to rationalize the denominator, we need to make our denominator perfect. If it already is perfect to begin with, we can just simplify it. So you don't have to make it perfect if it already is perfect. In this case, we must multiply by the cube root of 2 squared to make this turn out to be perfect. Oh, well, instead of multiplying by the cube root of 2 squared, we can do that, but we can also use our rules that we just talked about. So the simpler way to manually work this problem is to switch it and reduce it. Then we can just simplify this expression. So we didn't need to do that. Here is example C is an example of what we were talking about up here, where we just multiply by the cube root of 2 over the cube root of 2. So again, these are rules. If it's already simplified, go ahead and use it. If you can reduce by combining with rules for radicals, do that first and you won't have to use this technique. Here it shows these problems, okay, being worked out on the calculator. So we get the answer to both the first 2 problems, and then it shows the last answer being put in. So let's go ahead and take a look at that last answer to see what it turns out to be. So we'll go over to our calculator and we'll want to clear it out. So we'll go to menu, 1, 5. Then we'll want to do the last problem. So we'll go to control and our index, put our index to be 3, move over to here, put 5 divided by 4. So rather than use the fraction template, we'll just go ahead and put it in this way and press enter, and we see we turn out with the cube root of 10 over 2, which is the same answer we got on our calculator. So here we talk about rational denominator. It shows some more examples of this. If we go back to our home screen, go back to our current one that's in here, and this is example 3. So if we flip ahead to go one more, we end up looking at these problems. We see that this one turns out to have a radical in the denominator. We see that this one turns out to have, okay, the y over 2 and the 4/5. So when we start doing these things on our calculator, sometimes we're going to get the answer we're looking for, sometimes we're not. That's why knowing the manual technique is necessary. And this is showing the same screen that we see on our calculator, and that concludes this lesson.